I think we've mentioned a few themes here around the integration, right? You have things like electromagnetic analysis and just pure design suites being brought in alongside CAE suites. But what do you think is the next round of cross-disciplinary integration?
Looking at where we are today, just getting all these workflows sorted out is a challenge in its own right. I do see AI having impact in areas, like certainly in CAE, there has to be a lot of testing and benchmarking and so on. I can see AI playing a big place there. Um, in terms of the coding, I think it will change in the CAE space. I assume it will be the same in EDA, so that the developers will be focusing on the high value stuff, and the more churny stuff that can be done with artificial intelligence.
Hello, everyone, and welcome to the Altium OnTrack Podcast. I'm your host, Zach Peterson. Today, we're talking with Keith Hanna, independent consultant for the CAE PLM industry. If you have been paying attention to what's been going on in the EDA industry, you're probably aware that there have been some very high-profile acquisitions, including the acquisition of Altium by Renesas. I thought Keith would be a very interesting person to talk to about this, given his experience in the industry and across a variety of fields. Keith, thank you so much for being here today.
Thank you. Thank you for inviting me.
So before we get started talking about some of the stuff that's been going on in the EDA industry and engineering software in general, do me a favor, tell us about your background and how you got involved in your current field.
Okay. Well, I'm actually a chemical engineer by background. I did a PhD in chemical engineering, though my first degree was actually in mining. So I've come a long way into engineering software. But the thread through it all has been during my PhD, I started to write some code in the 1980s to solve the equations for fluid flow and heat transfer. And from that, I got a job where I got exposed to a very early piece of software called Fluent, which was a CFD code, computational fluid dynamics. And I stayed in that industry for about 18 years. As it grew from very small to maybe $250,000 a year in 2006, where it got acquired by ANSYS, and I stayed and got involved in ANSYS for 3 years in multiphysics. And then I moved into, well, it was still mechanical analysis, but it was a company called Mentor Graphics, as some of your listeners will know about, which is one of the big 3 EDA companies back in the day, and had a really interesting experience, and it exposed me to the EDA industry, given my background was mainly CAD, mechanical analysis, a bit of architectural work as well, and then stayed with Mentor until it was acquired by Siemens in 2017, I think it was. And then in 2018, I left and went to work for another manufacturing company that had some interest in electronics, and that was a company called Hexagon, who hadn't acquired a very old CAE company called MSC Software, and they brought me in as vice president of marketing to help turn around the marketing there. And then about 2 years ago, I left Hexagon to become an independent consultant, mainly working with small and medium-sized CAE companies. And laterally, I actually have also partnered up with a company called Cambashi in Cambridge here in the UK that does market analysis, market research, and CAE PLM industry. Not a lot in the EDA, but I do put out blogs, and recently I put out a blog that Zach saw on my opinions on the EDA industry clashing with the CAE industry, because I think it is a game changer for both industries, actually. And there are a variety of reasons behind it, in my opinion.
So before we go further, you've mentioned CAE a couple of times. For any listeners that aren't aware, could you please just give us a brief overview of what CAE software is?
Well, CAE, or mechanical computer-aided engineering, is a series of disciplines. The one that I started off with was fluid dynamics, In terms of physics, we've known about the equations of fluid flow, heat transfer of materials for the last 150 years. But it was only with the advent of digital computers in the 70s that we started to be able to solve these equations simultaneously and in real space and time in a way that was useful for predicting mechanical effects. So that was fluid dynamics. It kind of came out of Imperial College here in the UK in the 1960s and 70s. But prior to that, there was some work done on structural analysis. Came a lot out of the moon shots of the 60s, actually, because we'll need to simulate the structural effects, structural stresses and strains and cracking and so on. And that's been going for about 50, 60 years. And then the other big areas are electromagnetics, which obviously dovetails very nicely. Well, in fact, all these areas dovetail nicely with EDA. It's just that historically, the EDA industry grew separately from the CAE industry, from the CAD industry, and computer-aided manufacturing as well. And of course, now with so much electronics embedded in mechanical products, they're becoming intertwined and seamless in many respects.
So obviously you have a lot of experience working in these areas of software, and you've identified one evolution, which is, I think, probably part of a broader trend or a broader theme across engineering disciplines or engineering software. What can you tell us about that, and what evolutions have you observed over time?
Well, as I said, what I think I've observed is I've obviously come from a mechanical background, did a bit of electrical engineering at college and very little electronics. And obviously, you go into work, and I worked in the real world before I got into software, and you're solving mechanical problems essentially. But I've noticed maybe over the last 25 years, even if you think of our automobiles, how much electronics there is in them today, you're essentially, when you go to buy your latest SUV, you're buying an electronics box on wheels, basically. The mechanical side is still there, but it's all being driven by CPUs and control boxes and LED lights and a host of things. And in fact, BMW reckon maybe half the value of their car is the electronics, and a lot of the profitability is in the electronics. So electronics has become embedded in a lot of consumer products, mechanical products, in particular in the auto industry, the aero industry, but consumer electronics it generally has exploded, I would say, during my career. And that has essentially meant that if you want to design a mechanical product, you have to take into account electronics and vice versa. The two are unavoidable. And usually you find, as electronics, when I was working in Mentor Graphics, they were primarily quite strong on PCBs, and obviously PCBs are in every control unit. But as they become more denser in electronics and integrated circuits and all sorts of power electronics has come in now as well, it starts to have strong mechanical effects like thermal. Thermal is the biggest source of failure for electronics. And obviously if an electronic component fails, the whole of the mechanical product fails. So being able to simulate thermal effects, stresses and cracking, vibrations, dust and humidity can also, cause failure of electronics. So all of these need to be simulated more and more. We're discovering in all of the major industry sectors. And obviously EDA has come out of the semiconductor industry, but I kind of view electronics as both a vertical and a horizontal in an industrial sense. And by that, I mean, it's a vertical in terms of semiconductor manufacturing, but electronics appears in automotive, in aerospace, in consumer products. Pretty much every other industry sector has electronics. So it transcends the horizontal. And that's why I think EDA has grown so much over the last 10, 20 years. And what is probably most interesting, it's come in and taken over the CAE, or is starting to take over the CAE market, and increasingly PLM, product lifecycle management, is colliding into EDA. And Kambashi reckon EDA is maybe about $15 billion a year, including Altium. PLM, which includes CAE, is about 30 billion. CAE is about 8 billion. So those are the sort of numbers. They're all kind of growing at this 10% year on year organic growth. But it's still nowhere near saturated, and there's still a huge opportunity and headroom for growth, as I'm sure folks at Altium know that.
So what I'm really hearing here is kind of a fusion across disciplines. And I bring this up because if you look at some of the fusion or integration in the recent past, particularly between, PCB and MCAD, it has a lot to do with like placement, place and route. It has a lot to do with fitting in an enclosure, which are obviously really important because they're such huge drivers of the user experience and the usability of a product. So I don't mean to, minimalize that or anything. But it seems to me that there's been an inability to access some of these higher level important things that you mentioned. Things like thermal simulation, things like CFD, especially I think for power products that use airflow for cooling and stuff like that. It's not only is the software more specialized, but the direct integrations just haven't been there really until recently. Would you agree?
Yeah, well, actually, the company Mentor Graphics that they acquired, that I worked with for about 8-10 years, a company called Flowmerics, they tried to span the two sides of the chasm, as it were. And obviously, Mentor subsequently became quite proficient at it. But it is super difficult because the skill sets are very different in EDA than they are in mechanical. And the time frames are different as well. Obviously, for any consumer product, you want to be able to virtually test it as quickly as possible. And in the early design, you want to do as much simulation before you commit to a prototype. And obviously, you ideally want to get it right first time. And I've designed out all potential flaws. And as I said, one of the things that I've observed in certainly my interactions with the EDA industry is the language is completely different in electronics and compared to mechanical. So when I first appeared at Mentor Graphics in Portland, everybody's talking systems. And in my brain, I'm thinking systems in terms of mechanical systems or fluid systems, whereas in electronics, it has a very, very different meaning. And so there was always this concern that, yes, an electronic PCB or an IC could be designed, and then it was thrown over a wall to the mechanical guys, and then thrown back again, and you would get this sort of ping pong that was going on, and ideally you want it to be iterative, and they're both speaking the same language, not in a actual sense, but in a figurative sense, and actually the key thing is what is now called the digital thread. We generate shed loads of data. In simulation, you can get terabytes of data very easily, particularly in the mechanical space. And then how do you use that data in a very intelligent way, both from the electronic design space and then the mechanical analysis space, but also the CAD space. And then ultimately, all electronic products have to be manufactured, and you actually have other software involved as well, like embedded software, which also has to be designed and applied to these products. And then in manufacturing, you have MES software, ERP software. There's this huge thread of simulations and data all the way through a modern product, and that's just to have it manufactured. And then obviously during use, it deteriorates, it may fail, it may be recalled, there may be all sorts of issues that weren't anticipated. And then ultimately in the modern sustainable world, we want to recycle all this stuff. So somehow getting all that together is super difficult. And do I think any companies doing it all today? No, not really. You get ones that are good at one part of the spectrum and one's good at the other. The only one that I've seen is Siemens. When I was there, And that was quite an interesting one because they were essentially a mechanical company, 200 years of history, got into CAD maybe 15 years ago, then got into computer-aided engineering, and then acquired Mentor Graphics. I think Mentor Graphics was the first significant EDA, PLM interaction in terms of a big acquisition. And today they're stitching all this together, and they have layers of other software underneath for data management, and then obviously I'm not even talking about AI. That's coming in, and that's going to impact the whole of the industry in ways still to be determined.
Yeah, it wouldn't be an Altium podcast if we didn't mention AI. Now, you mentioned
No,
acquisitions.
I would say from my perspective, in the PLM CAE industry, the acronym or the word AI is used. I'm not sure it's real AI at the moment. I think there's still a lot of machine learning going on, which I've seen work and is very effective. True AI really depends on good algorithms and enough data to train the algorithms well. I can't speak much for the EDA industry, but I do know in the computer-aided engineering industry, you can predict the wrong answer as much as the right answer if you miss out certain physics or you make assumptions and so on. So, AI could just accelerate that failure, if you see what I mean, if it's applied wrongly.
So getting back to acquisitions for just a moment, M&A is not a new thing in our industry, whether it's CAE or PCB or EDA or whatever, right? M&A has been going on for a long time. I think one of the earlier M&A activities within the last 5 years, obviously, Siemens acquiring Mentor, I think that raised a lot of eyebrows. But, it seems to have culminated in 2024, where we've had a pretty huge year in terms of M&A activity and a lot of high-profile acquisitions, particularly of names that I think people thought were always going to be independent. So what makes all this activity different from prior rounds of M&A? Is it just deal sizes? Is it the peculiarity of cross-discipline M&A? With Renesas acquiring Altium, it's a semiconductor manufacturer acquiring a PCB company. I think that makes people scratch their heads a little bit. What do you see as being different with this round of M&A compared to prior rounds?
That's a good question. I would say the electrification of everything, which goes back to my earlier point on, when I buy a mobile phone, I'm buying a mini computer, which, is more powerful than what I used to have on my desktop probably 10, 20 years ago. So the electrification of everything, or electronification, if that's the right word, of everything has a huge impact. If I look at it purely from the CAE side, if I look at a company like Ansys, the big shock was Ansys being acquired by Synopsys. Because they're not far off the same size, actually. There's maybe only a few $1 billion a year between them in terms of revenues. Ansys itself was notorious in the CAE PLM space of just acquiring companies over the last 20 years, including the one that I started off in, and very good at taking them and accelerating the revenue growth from the companies they acquired. So they became essentially a multi-physics company. Yes, they acquired Apache and got a bit into the electronic space, but not in terms of pure EDA. And then, obviously, you've Synopsys, who maybe had a bit of optical simulation, but not a lot of other pure CAE play. So that is the big play that is most interesting. And it'll be fascinating to see how it plays out, to be honest, because you've two very different cultures. Will Synopsys come in, put their own people on board? Will they leave Ansys, as a revenue generator? Will they start to integrate products a bit more? We simply don't know. The potential there is to add value, but as with all acquisitions, at least half of them can fail according to shareholder value. So it's to be determined. I think Siemens have done pretty well with Mentor Graphics from what I understand. And obviously they've just announced this big acquisition for Altair, which is another mainly CAE company. Yes, they have some electromagnetics, which I think Siemens really wanted. And so that will be more of an add-on, I would say, at Siemens. What is interesting is the multipliers. 18x, 16x. Wow, those are big numbers. So someone's expecting huge growth there. I think 10, 15 years ago in CAE, the multipliers were maybe 6x, 8x. So now that we're up at twice that, maybe plus. That is really fascinating, and you could say Synopsys are betting the farm on this one, aren't they?
Yeah, that's what it seems like. The multipliers were, I think they were a bit eyebrow raising too, because like you said, they used to be smaller, but I wonder if part of that is just because if you look, broader within the market for publicly traded securities, the multipliers are already higher because growth is so good, everybody's doing so well, they just had to pay more. They had to make the offer rich.
And there, from a CAE perspective, there aren't that many of these independents left. In the last year, Altair has gone. ESI has been acquired by Keysight, which is kind of electronics company. Very interesting acquisition there. So basically, if an electronics company wants some mechanical analysis, better start looking around because there aren't that many big ones left. I can only think of 2 or 3 that are, still potentially available. And vice versa. So I think there's maybe a need in the EDA side. And also it's interesting to see how the PLM will respond to this. Because the PLM world is very much, in my opinion, driven by geometry. It came out of the mechanical CAD, the CAD industry, and then CAD is used in manufacturing and so on. And obviously EDA has come from a different direction. So how these two will interface will be really fascinating, in my opinion.
So do you think that on balance, this is all going to be a good thing for engineers? Now I ask this because whenever something like this comes up, existing user base for these products, I think many of them complain. Maybe complain is not the right word, but they express a lot of fear that the tool that they love is going to change so much, or the price is going to go so high that it's no longer accessible to them. And I don't want to downplay that. I do want to be cognizant of that. But given enough time and given enough effort by the companies involved in these deals, do you think it's going to be on balance a good thing for the existing users and for new users?
Well, there's always the argument, are you, reducing the field? You're less choice usually means more of a monopoly. Prices can go up, yada, yada, yada. The other side of the equation is, if I look at Siemens again, they acquired Mentor Graphics. They've invested a lot in CAD underneath the EDA products. And I see huge improvements there compared to if they hadn't acquired Mentor Graphics. So it wouldn't have been as far forward with the products there. So, and also you get access to other products in the suite that Mentor Graphics or Siemens offer. And I would expect the same with Synopsys and Ansys, and similarly with Cadence and Beta CAE. To be honest, the one I still struggle with is Altium and Renesas. Yes, I can see it at one level from a pure electronics play, but I'm not sure on the wider PLM MCAE market if it has that much impact.
I think we've mentioned a few themes here around the integration, right? You have things like electromagnetic analysis and just pure design suites being brought in alongside CAE suites. But what do you think is the next round of cross-disciplinary integration? I have an idea that I can speculate on, really maybe 2 ideas, right? One of them could be something where I guess you bring embedded software developers back into the fold of electronics design, because currently everything they do is totally isolated, right? None of that stuff talks to each other. The closest they get to talking to each other is on GitHub. And then probably the other one is something to do with AI.
Looking at where we are today, just getting all these workflows sorted out is a challenge in its own right. I do see AI having impact in areas, like certainly in CAE, there has to be a lot of testing and benchmarking and so on. I can see AI playing a big place there. In terms of the coding, I think it will change in the CAE space. I assume it will be the same in EDA, so that the developers will be focusing on the high value stuff, and the more churny stuff that can be done with artificial intelligence. Um, I, I I think just doing what we're doing better and faster is a significant step forward, if I can say that. And don't forget, we've also got, at least in the PLM CAE, certainly in the computer-aided engineering, it's terribly number crunching. It literally is rocket science. It literally, when I first did a Formula One simulation of a complete car in 1996, it took 6 months to do it. Today they're maybe doing it in 10 minutes, but they really want everything in real time as quickly as possible, which in EDA is more, acceptable. But in the mechanical space, we're still behind there. And, with what NVIDIA are doing with their processors and cloud computing, I think is also going to have a significant play. And actually cloud still hasn't really, I don't know what it's like with Altium, maybe you can comment, but in the mechanical space, it's more used as an auxiliary rather than a pay-per-use model. That still hasn't really come to pass, because a lot of the mechanical simulation tools are still very hard to use. You don't quite know exactly what you need when you start a simulation, so having a general purpose code can make a lot of sense. But it is very intensive. So I think all of those things, plus data management and data mining, someone once told me there are millions, probably billions of simulations are done each year, but very little of the data is used intelligently to help subsequent simulations because it's all kept proprietary within the customer base. Now, I think that's a huge opportunity that still hasn't been mined in the PLM field, at least.
Yeah, you brought up cloud, which I think is interesting because, obviously Altium is, trying to lead in the cloud thanks to the Altium 365 platform. I think usually when people hear cloud and EDA, they think, oh, you're putting my PCB design tool online, or you're putting my, my packaging design tool or whatever online, or you're putting my simulator online, right? I think those are the obvious ones. It doesn't always work out because, online requires a lot of bandwidth to even do some of those activities. But there are probably opportunities with cloud that no one in the EDA space has even thought of. And you kind of hinted at one, which is like infrastructure.
I think maybe the mechanical world is ahead of the EDA world in terms of using cloud, because it maybe has had to, because it wants this speed up. And that's possibly where EDA will learn more from the mechanical side than vice versa. The problem is sometimes you give in one hand, you take away with another. Yes, it's great. We've got so many data centers, but what is it? Data centers now are 8% of world emissions of CO2, and we're not building them fast enough, and so on. So maybe there is an argument for a lot of these engineering simulation tools to be more efficient than what they are today, better architected, better designed, because a lot of them are like a house that's had a wing built here and another wing and then another floor put on top. They're not optimal in many ways for the modern, computer code, as it were.
I think that makes a lot of sense. So would you be willing to speculate what might be some of the next names to be acquired by the bigger players? And maybe if you can't mention specific names, maybe
I can mention names because it's not like I can observe the market like anyone else can. If I look at it from a PLM perspective, the company that seems to need to move now is Dassault, which is one of the big three or big 4 or 5 PLM companies who doesn't have much in the EDA space. So are they out looking? Is Zuken free? Who knows where? Zuken is one of the last big independents, isn't it? I think Dassault probably still needs some fluid dynamics capability, and there are some independents there they might be interested in. PTC, does Cadence want to get into CAD? Is there a nice marriage made in heaven there? You could look at it that way. And then Autodesk, they're there. What's happening with them? Are they going to get into EDA in some way? Because you can't. I don't think you can afford to be off this bandwagon. The bandwagon has started, with Siemens and Mentor, and now Synopsys and Cadence. How's everybody else going to respond to this? And obviously Altium, Altium, as I say, that was a bit of a left field one with Renesas, but
yeah, it's interesting because it feels like all of this is coming at a time after we had a semiconductor shock due to COVID and due to demand spikes. And all of a sudden there is worldwide investment in that production capacity. So now there's renewed focus on electronics. And then it suddenly seems like, oh, there's all this really great software out there that's making a lot of money and we see the market growth. Now all of a sudden it seems like the right time to invest in these companies.
I think there's another factor going on, and I'll probably comment on it sometime next year. And, it's a sad factor. It's geopolitics. Let's be honest. Even my daughter came home from school and he said, is there going to be a World War III, Daddy? Wow. This is from a 12-year-old. And of course I say, I hope not. But, in my career, I've been through the Cold War when I was younger, and then, the fall of the Berlin Wall. And then everybody was friends and we were going globalization full guns. And now we've got this situation where there's several, very, very nasty wars going on in the world. And of course, don't forget, all of this technology is dual use. And I think part of the impetus, the growth in this is, the demand for defense, the demand for military. And look at you guys in the US, EDA, concern over PCB, in Taiwan and so on. So there are multiple factors going on in the background that didn't exist, or at least we weren't concerned about it 10, 15 years ago, I'd say.
That's a really good point. I had not even thought of, geopolitics playing a role in this, but I think that probably looms in the background, and, it's one of those things that you think about without thinking about it, if that makes sense.
And don't forget, a lot of, certainly in the mechanical space, a lot of the computer-aided engineering technology came out of the defense industry, came out of the Cold War. And we see in, Ukraine, some of the electronics is, drones and so on is exploding, and cameras and so on. We are in a really weird time, I'd say. But electronics is at the forefront of all these different areas, or has to respond to what's going on in the world.
We're getting up here on time, but I have one last question here. And it relates to, of course, what's going on in the business world here in EDA and in CAE. Now, 2024 was, of course, a landmark year for M&A, but it also feels like it's a landmark year for startups. And a lot of those startups are integrating AI into what they do. There's a lot of EDA startups. They built their tools around AI. They've built their tools to run on the cloud. And those kind of seem like the wild cards. They seem like they could be the next big thing if they execute properly and if they create the most value for users. So does that then lead to potential IPOs in the future? Is the field for EDA players going to expand, or are they just going to get gobbled up by the big three?
My gut feeling is they'll get gobbled up. That's my gut feeling. I'd like to think they could grow and become a big player. Certainly in the CAE space, a colleague and I, when I was at Mentor Graphics, we did an interesting backward-looking historical analysis and discovered that from your first concept of a CAE product till it generates real revenue was about 7 years. It was quite uniform across many sectors. I don't know what it is for EDA. So I think that will be compressed now. It'll be shorter. And don't forget, a lot of the AI in this engineering simulation is still dependent on data being produced by these existing codes. So it's hard to see something coming along that would displace the incumbents and become huge. I can't really see it. I'd be frankly surprised if it happened. But you're right. There's a huge amount of VC money going after AI. What I have observed in the CAE space is I don't think there are enough benchmarks, cases that you can test the AI codes against, which I think is super important, because yes, you can come up with all this clever AI, but if it predicts the wrong answer, then it's not a lot of value to the customers. And certainly industries like automotive and aerospace, they will demand this. So AI is interesting. I think it is going to move the dial. But I think it's going to be a rapid game changer? I don't think so.
Yeah, I think that any innovator that wants to get into this space has to think about this, because VCs want to know what their exit is. The founders have to think about what their exit is too. And I feel like over the past, 10 years or so, the only exit has been acquisition. And it sounds like you think that's going to continue to be the case.
Yeah, maybe I'll be proven wrong, but certainly, I can't speak totally for the EDA industry, but certainly in the mechanical design industry, it is still relatively conservative. There is this inherent inertia, and as such, it is hard to displace incumbents, and they keep going for many years.
Sure. Well, if anyone tries to do an IPO in the near future and they do an actual IPO and not a SPAC deal, we'll definitely have you come on to talk about it, because this is a side of the industry that we don't talk about enough, and we certainly don't talk about the business side enough. So I want to thank you so much for being here, Keith.
Okay, thank you for your time.
To everyone that's out there listening, we've been talking with Keith Hanna, independent consultant for the CAE PLM industry. If you're watching on YouTube, make sure to hit the like button, hit the subscribe button. You'll be able to keep up with all of our podcast episodes and tutorials as they come out. And last but not least, don't stop learning, stay on track, and we'll see you next time. Thanks, everybody.